Let me put it on record. Yeah, the recording is on. The plan is, since we are doing the take home, right, for final exam 4 take home. So there won't be any review for the final, but I mean not in class review. But I'm gonna upload a video lecture for Friday class, because Friday there won't be any in person class. I'm gonna upload a video lecture for Friday class, as like I'm gonna talk about the exam. Okay, so that's the plan. But you can reach me anytime in Teams if you have any question about the exam. Anything else you want me to share? It was good. That's good. Okay. So, okay, theory wise, a quick review. What did we learn? Basically, every time we're doing a problem for this class, we're doing the conservation of linear momentum. You notice that, right? Conservation of linear momentum and the conservation of energy, right? Okay. So, um, the other thing that we started in last class, we haven't done any math yet, is coefficient of restitution. Just remember that coefficient of restitution, the change of velocities after the impact divided by change of velocity before the impact. Just remember that. So why you are not seeing anything up there? Sorry. Ah, the only day when I have too many agendas is acting up. I gotta restart it. I'm doing it. Hopefully it is gonna resolve. Anyway, so the two problems that I'll be doing both deals with this coefficient of restitution E. Remember, the E is 1 perfectly elastic, E is 0 perfectly plastic. So those equations that we'll be using, and the moment you would be seeing it here, I mean the restart happen, then you would be seeing the problem. Okay. In meantime, if you have done the class before, you can start. And let me restart it here. So you can start reviewing the coefficient of restitution equation. Okay. I'm gonna try to show it to you as well. Immediately it will gonna come, because that's the equation that we'll be using. Again, we'll be using the velocities after the impact, right? And velocities before the impact. So it just says here, coefficient of restitution is a ratio of particle relative separation velocity after the impact. Okay, so VA to the particle's relative approach velocity before the impact. Now, obviously, when you're seeing this, it is referring to this two ball that is coming, say like A and B together. You're not seeing it. This time you're going to definitely see it. Just wait for a second. Yeah, you're seeing it, right? So this is the equation that I'm referring. So E is again difference of velocity after the impact, which is BB. It's too much writing here. Let me try to take out everything and try to point out. So you see, first of all, this E, coefficient of restitution for the central impact, the E can be defined as the ratio of uh, relative separation velocity after the impact, so which is bv2 minus va2. So A and B, you can consider those two balls or objects coming together, divided by to the particle relative velocity before the impact, which is va1 vv1. So those same two objects, initial velocity, one is referring before impact, two is referring after impact. Those are the things. Okay, so this is the equation for E, and I did talk about it. E should be 1 for perfectly elastic, E should be 0 for perfectly plastic impact. Now, in between the 0 and 1, there are different values depending on how elastic or how plastic that those two objects are impacts that we are referring. All right, so basically, this is the equation that we'd be using, and these are the things that I did cover in last week maybe at some point. There's this oblique impact kind of covering the same thing. Just quickly going through this. I'd like to just jump into our problem. So the 7 and 8, these two problems that I have. Let me start reading through the problem. Okay, you can do the same. Let me open my notes. All right, so my notes is here. All right, perfect. So it has a ball which come to a wall, a vertical wall, and initially it does have a velocity of 20 meter per second. When it impact on the wall, it does have an angle of 30 degree. And you were asked to find those two unknowns that you're seeing obviously here, VB2 and theta. So theta is the angle that the ball is coming back with horizontal when it come from the wall. That's what is referring with theta. And obviously the velocity VV2 that once it come back from the wall. Okay, so those are the two. And I like the E equation that I was just covering. You remember, right, Joe? Over there you had like this A and B, two objects, right? Here just simply one ball is hitting on the wall and coming back, right? Previously you have two balls coming, collide together, impact happen and go back, right? So that's why you have A and B, two different velocity. This time I just have one ball, right? So the E equation, when I'd be using it just for one ball instead of A and B, just to give you a heads up on that. Okay. All right. So they gave you the value of the E as the E that I was explaining. Relative velocity after the impact divided by relative velocity before the impact. Okay. That's the E, if you remember. Okay. All right. So let's start this. So givens, okay. Any questions so far? And then you see here this BV1, the velocity given as 20 meter per second. So you can write it here next to it is like is velocity of this ball before the impact. Okay, if you'd like to get more info about that. So one refers to before the impact. Let me put it here anyway. So one refers to before impact, right? And two refers to after impact. All right, so then other things they gave you, this one I would like to write anyway. So even though it's written here, coefficient of restitution, I didn't write it before. So coefficient of restitution, okay, that's E. The value of 0.75 refers, is it more of a plastic collision or more of a elastic collision? More of elastic collision. Thank you. Because the E perfectly 1 means perfect elastic condition. All right, so you'd like to draw a free body diagram as well, right? If you're gonna draw like this wall as like dotted line, right? And this ball, I don't know, maybe this color, fancy color, green color. All right, and then the impact velocity is pointing out by this arrow, okay, which has the angle of 30 degree with what? 30 degree with the horizontal line. Okay, and then obviously it does have this velocity BB1 given, and it does have two components, right? I'm gonna do these components or write these components in red color. Okay, so okay, and then this one would be BV1 sine 30 or cos 30. Thank you. And this one would be VB1 cos 30. All right, so then after the impact, obviously, we're going to come back, and the coming back direction would be obviously seems like something similar to like this, right? You've seen this, and this is the angle theta, right? This theta is not known. You have to find it. Not only that, you also have to find the velocity after the impact happened. Okay, those two are the unknowns. And you can write this thing here that these two things that you're trying to find, right? So find the velocity of this ball after the impact. So you can write it here after impact. That's what you're gonna find. And the theta, you can put as theta 2 as well. It really doesn't matter. This theta is referring to the angle of the ball is coming from the wall. Is got it so far? All right, perfect. The solution. We have quite a bit of agenda. Let's try to keep up with the work. Okay, so the first thing is like the impact problem. You can solve it in x and y direction momentum. Okay, So we'll be solving it in both x and y direction, the momentum I'm talking. So let me write it. So momentum of the ball conserved in y direction. So let me write that general statement. So impact problem by solving x and y direction momentum conservation, right? Conservation. Okay, then you'd like to write momentum of the ball conserved in y direction, okay, in x direction as well. So we're going to write the equation for y direction. So momentum of the ball in y direction, which would be in y direction, you said it by yourself, right? You see this velocity vv1 sine 30, that's in y direction, right? So obvious. So you can write that. So vv1 sine 30, okay, and it needs to be multiplied with the mass of the ball, right? You can assume the mass of the ball is m, okay? So let's say like this is m, is the mass of the ball, right? Let's say this is mass. Okay, that should be clear enough now. So you can write this m, and that one is before the impact, and it should be conserved before and after, right? So right side would be again the mass of the ball, and then this VB2, and this one would be sine theta. This theta or VB2, nothing that you know. Those are the things that you'd like to find. Now you have one equation. This theta in this side would be 30 degree. Don't get confused with before and after impact theta. So in this one, here on this equation, you have this one equation, two unknowns, right? Right side, both of them unknowns. So we've got to take care of something regarding that. This m, you don't care about it because it will going to cancel out in both sides, okay? So if you're going to write this whole thing again, so this bv2 sine theta can be written as vb1, right, sine 30. You can start plugging the values. So vb1 is like what, 20 meter per second sine 30, and that should be 10 meter per second. It's the number one, right? Okay, so you got to get another equation for sure, right? How are you going to get it? Is there anything else given? The E, right? The coefficient of restitution. You know the equations for E, which is what? Like the change of velocities after the impact divided by change of velocities or relative velocities before the impact, right? So before the impact, you know the velocity. After the impact, you don't. But if you have a ratio of values known, that could be another equation. You guys get it? What I'm saying? So now you have two equations, two unknown, VB2 and theta. Everybody got it? How many equations you need to solve two unknowns? Two. That's always the case, right? So you had just one equation with two unknowns, so the other one must is to be fine. And you do have a clue from coefficient of restitution. Let me write that. So coefficient of restitution E, right, should be written as, now here's the trick. So you want to always use the modulus sign or absolute sign. What does it do? If you have a negative value, then it will gonna, because the E should be always positive, okay, for sure. So that's why the difference should be modulus or absolute value or positive. So you do have, like, before the impact and after the impact, right? You do have the wall. What is the thing that's happening here? The ball is hitting the wall. So ball is that is moving, the wall is not, but the impact is happening in between. Okay, so you got to count the wall velocity as well. So before impact, after impact, is the wall moving at all? No. So you can obviously put, for understanding purpose, I'm going to put those and then I'm going to name them as 0, right? So that's for the wall. But the ball does have velocities before and after both. So we're going to write them as well. So I can write this. So VW, the wall movement in x direction, right? Now you can do it in both x and y direction. You have to understand that, right? Because it has an angle. You can't just arbitrarily put the angle velocities, okay? It needs to be x and y direction, either x or y. All right, so if you're gonna put this wall velocity in x direction, I'm gonna name it shortly. Let me first write it here. And vvx2, I didn't quite mention this thing before, so I'm gonna explain it a little bit because these are in x direction only. And then this wall velocity vwx, and this is the same thing, it won't be changing. And before what? Before the impact happened. Now here I can explain this thing a little bit for note, side note or something, side notes, right? This vwx is the x direction. Wall is not moving in both x and y direction, but you can name it a little bit self-explanatory way. So x direction, velocity, VL dot means velocity of wall, right? So VL means velocity, and then you have this VVX, okay, 1 and VBX2. I'm writing this x component of this before and after velocities for the ball, okay, before and after the impact. So this could be before and after impact velocities, right? Velocities in x direction, okay? If you have understanding issue of this equation for coefficient of restitution that I wrote, then you should be writing the side note, okay? And obviously this would be 0, right? And we know this value as like 0.75, right? And we have this VBX2, you have a negative here, and I really don't care about the negative y because I have an absolute sign, right? Absolute will gonna take care of my negative to positive, VB1. Okay, so then you'd be writing this thing is a little bit descriptive manner. You know, the x component is cos theta, VB2, and VB1 cos 30, right? See that? Everybody agree up to this? Okay, perfect. Then what? Then you're gonna just simply start to plug the values. So you have this 0.75 here, right? And then you have cos 30 value is I didn't quite explore that. Let me write it as like 20. Let me rewrite it this way. So like I have VV2 cos theta, right, equal 0.75 VV1 cos 30, right? Okay, so then I would be writing this VV2 cos theta equal 0.75, this 20 meter per second, and cos 30. Okay, I'm gonna have this thing 13 meter per second. That is my VV2 cos theta. Now, how am I gonna find it? Now, if you notice, I do have this thing here, right? And I have this VV2 sine 30, okay, and this would be written as 2, and this would be written as 1, okay. If 1 could be rewritten here, so this is 1, sine 30 equal 10 meter per second. I'm gonna name it 1 again, right? So now you have these two equation. Can you find the value of theta? Can you? And value of VV2? What is the value that you found? Alyssa? Is it 16.4?
I didn't solve it.
Oh. Anyone solved it yet? Just take 5 minutes, solve it, like, and then we'll have 20 minutes to finish the second problem. It should be all right. We gotta solve 2 problems. So how are we gonna do it? Any idea? You can divide them to find the theta. That's obvious. VV2 is gonna cancel out. That's the one part, right? Makes sense? Divide both equations. Divide 1 by 2 to find the theta, right? Does it ring a bell? All right, and that one is easy. That one should be, because VV2 should be cancelled out, right? Okay, and then Finding VB2 is a little tricky though. Once you find the theta, then you can find the VB2 because, see, you remember sine squared theta plus cos squared theta equal to 1, something like that. Okay, so just try to do it. At least try it first as much as you can. Oh, I'm sorry. This is not. This is. I think I did a mistake. This should be theta here. I don't know why I did write 30 here. I have a typo here, by the way. I'm sorry, guys. Now we're talking. I was thinking, what is the problem? Everybody correct that typo here. So now can you solve it? Now I can give you a clue though. Sine squared theta plus cos squared theta is what? Anybody remember from trigonometry? 1. Thank you. Do you remember this equation? Okay. Everybody remember this equation? Delina, you remember this equation? Sine squared theta plus cos squared theta equal to 1. Alain, you got it? That's the equation. Remember, that's the trigonometric identity. Okay, you gotta remember that. That's from geometry. Okay. So once you know this, then this is not a difficult problem at all, because what you gotta do, you gotta do this equation 1 square plus equation 2 square. So that's the hints, right? To find what? Find the value of BB2. And this value you should be finding. Let me give you the value. This value should be finding 16.4 meter per second. And you can do it this way. Divide equation 1 by equation 2. And then you can find the value of the theta. And the theta value would be 37.6 degrees. See if you can able to find it. You just have to remember a little bit of the trigonometry that you did before. Okay. Try to do 3 minutes at least. That way you can use your brain a little bit. Okay. What's the class number?
Well, I went to 3D printing. I just didn't bring my backpack. I just had to grab it.
Yes,
I can just watch the video. Or
you watch the video and you do it at home by yourself.
Yeah, that's what the plan is.
Aline, you found any value? You getting it? Who else got the value? Lisa got the value? Both of them correct? Yes. It's fine. 12.99 or 9 or 9. Yeah, it's this alright. You can definitely round it. But did you get like 16.4? Okay, and did you get like 37.6? You know how to do it. Like, if you divide them, then it will be 10 theta, right? You're dividing 1 by 2, then it will be sec theta. But you want to divide, 1 by 2, then it will be 10 theta, because sine theta divided by cos theta equal to 10 theta. So you want to do arc tangent. You guys remember the arc tangent? Arc tangent. In a calculator, you got to use this arc tangent. Inverse tan, exactly. So arc tangent. So inverse tan to find the theta, right? You have this, tan theta equal to what? Like 10 divided by 13. So some value less than 1, whatever that value is. Arc tangent of that value will be giving you the value of theta is 37.6 degrees. How many of you get this value already? So well done, Lisa. Arlene, you got it as well. Both of them. Sure, if you are still working. All right. While you are working, seems like you guys got it perfectly. So I'm gonna start to write it in the class note. So you're not gonna falling behind. You guys remember, I have another agenda, another problem today. Okay. So I'm going to take out all those things that I wrote here. You know those values already. One is the 16 point something, another one is the 37 point something. Okay. So what you got to do, the first one, you got to write this BB2 2 sine theta, the whole thing square, plus BB2 cos theta, the whole thing square, equal 10 square plus 13 square. That is the tricky part to understand. Okay, you are adding up after squaring them. Okay, once you did that, then obviously this is BB2 square, okay, sine square theta. I don't know if you remember that sine square theta needs to be sine square theta needs to be written on the n. The square needs to be on the n, means the superscript of n. You guys remember that? Sine square theta. So sine square theta plus BV2 square cos square theta. Okay, and then you have this 10 square plus 13 square, bless you. So this BB square, then it is sine square theta plus cos square theta. Okay, this cos doesn't look great. Cos square theta. Okay, and then you have this 10 square plus 13 square, right? And then you know this, right? You'll apply this here. So you're gonna have BV2 square. This become 1, right? So sine square theta plus cos square theta is 1. So you have this 10 square plus 13 square. Then you can do a square root, right? 10 square plus 13 square. 13 square is 169 and 10 square is 100, if I'm not mistaken. All right, so if you're going to do the math, and then we're going to come up with a value of 16 point something, 16.4 meter per second. That's your BB2. This B doesn't look great, but now it is. So again, you can box it and you can put the unit here. You can also put the unit all over the places. It is perfectly fine. In that case, you just have to do it this way, right? Meter square second square. This would be meter per second, right? Either way, if you didn't have the unit before, you can put it at the end as well. But I would strongly recommend to put the units while you're solving the math. So this one you can name it as like, okay, this is the velocity of the ball after the impact. All right, so our second goal is to find what? Theta. So find theta. And to do that, right, what are you going to do? So you got to divide both equations, right? You had this VV2 sine theta. This equation number 1. You're dividing VV2 cos theta by equation number 2. And the right side, you have 10 meter per second and 13. So this meter per second we're going to cancel out, right? And then this VV2 is going to cancel out. You're going to leave with 10 theta. And this is still, I'm going to keep it as 10 by 13. And theta will become 10 inverse 10 by 13. And this value will be 37.6 degree. You got it? Perfect. To wrap up the whole thing, we had two unknowns after the impact, the velocity and the theta angle of unknown. How did it, like we need two equations because of these two unknowns. One is the coefficient of restitution, right? E value given, that would be one equation. The other one is obviously the linear momentum in x direction. I believe we did it in x direction, right? So out of those two equations, out of those two things, we will have two equations and we have two unknowns like BB2 and theta. We use the sine square plus cos square equal to 1, that trigonometric relationship here. Remember that, okay? And the other one is like simply arctangent, okay? And that gives us the value of the theta. Any question? I do have one last problem, and that is also related with this coefficient of restitution. In the exam, you'd be expecting problem from coefficient of restitution. That's the thing that I'm covering, okay? All right, so this is so important, and then we'd be done with this chapter. in the exam, most of the thing you'll be seeing from this chapter, what we've done so far, right? This chapter 15 only, okay? And chapter 16 I'll start in next week, okay? I'll just simply review the theory a little bit, and two math problem we're going to do, okay? So what is that you're seeing here? This is a projectile problem, right? So we're going to combine the projectile problem here with this coefficient of restitution. Why? Take a look on this problem. So they gave you the value of the E. Other than this E value, if you're going to simply start reading the problem, it will seem like a projectile problem. Anybody remember the projectile problem? The projectile problem, Y equation. You have done it in physics lab, right? All of you, physics 1. Everybody remember? Physics 1 lab, projectile motion. Okay, so we did math as well at the beginning. Anyway, the Y equation and X equation. Anybody remember? What is this Y and X referring? So thing is, if you assume the ball or projectile, right, is running along X direction, here in this case, in X direction, right, it's running along X direction, and obviously it is going to fall due to the gravity, right? And when it is falling, it does have both X and Y movement, right? So you have the equation for the Y, right? How much of the movement of Y happened, right? You remember that equation as second order of time t squared, and you know the equation for X, like the X direction movement. So again, the projectile is moving from here, right? So the Y direction movement would be the height. You will understand, right? And the X direction movement would be right wherever the projectile is going to hit, from this point it starts to that point, the X direction movement. Does it make sense? The way I'm walking. So you need to use those equations, X and Y equations, on this problem. Okay, now how this E came up here, think this way. So when we are using the projectile or ball or whatever, right, that hit on the ground, and then it will going to come back again, right, obviously, and it will going to bounce several times. That's the real kind of scenario, right? And when the ball is going to hit the ground, depending on the coefficient of restitution, the ball is going to behave accordingly. Make sense? By the way, guys, when you are done with the class, can you please close the windows? Let's say email this sentence from this service today. Okay? Or I can do it as well if you forgot. All right. So everybody got it so far? Any question? It was ready for the problem? Let's start. Okay. So this problem, this says again, let me read through a little bit more. The tennis ball is served horizontally 7.5 feet above. So that's the Y value. Remember, that's what I was talking. The ground and strike is smooth ground at B. So that's what the ground strike happened. And you know the E value for this ball, that when it hits the ground. And this angle theta here, okay, that when it's come back, you got to find the velocity B and BB. So BA is what? Like when the projectile is moving from certain altitude 7.5, a projectile is the tennis ball or ball, tennis ball somebody is hitting. And the VB after it hits, right, is a very practical problem. Possibly you are working in a company, they manufacture the tennis ball, right? So you are calculating possibly the coefficient of restitution if you're in design phase. But if you design something before experimenting, you would like to calculate this B and BB. Okay. Okay, using the projectile motion analysis, determine the BA and the speed of the ball just after hitting the ground. Okay, so you gotta find the BB, you gotta find the BA. Okay, those are the things. Apply the coefficient of restitution in Y direction motion and the conservation of momentum in X direction motion. Okay, and find the theta using two components. This theta, remember, this theta, that the projectile is coming back from the ground. So that's what you're going to find. All right, the first thing I would like to do is draw a free body diagram. Okay, and then I'm going to draw the ground. So this is my ground, right? And the movement direction is, I can put it like, in red color. So many colors to use here. And the velocity when it strikes back, that's my BV. When it is started in X direction velocity only, VA, I can put a note here. So no Y direction, right? Initial velocity. You got it? All right, so this is straightforward. And this theta angle that you got to find. This is the theta angle, right? All right, and then they also give you this value here. $7.5 feet. And they not only that, they said like, okay, when the player hit the ball, it did bounce after 20 feet. Okay. So basically all you have a ball, you have the height where the ball got hit, right? You can measure it obviously. And you have the distance where it got hit on the ground, right? That's all. And you are asked to find the velocity when you hit the ball, the velocity of the ball, and you have to find the velocity after it hit the ground, that it is coming back. Not only that, the angle that it creates when it's coming back, right? So quite a bit of problem. All right, so let's try to solve. So this problem in a sense is not that bad because you do know the projectile equation, right? So we're going to start with that. But before even doing any of this, we're going to put a formal approach, givens, find those things. So this Sy is y direction altitude, or this y direction distance, 7.5 feet. The gravity, 32 point, because of you have dealing with the English unit, you'd like to use this 32.2, right? Not 9.81. Feet per second square, right? And the distance d, you can name this thing as d. The distance is like 20 feet. And then you have this initial velocity in y direction, right? Is 0. Remember I was talking about that. And you got to find three things actually. The initial velocity in x direction, which is BA. Okay. You can write VO. Basically, this is the same thing, VOX, in case if you're wondering, right? All right. So then you got to find the velocity after it hits the ground. Now, obviously, it does have two components, x and y direction, right? And then you also have to find the theta that it creates, the angle after it coming back from the ground. So these are the formal things, right? Haven't done anything yet for the problem itself. So on the solution, right? Running out of time, I've got to go a little faster. I have still 7 minutes. That will be enough, but still. So first thing first, the projectile y direction movement. So that's one of the reasons I actually don't do two problems in one class. But this is the time I actually have to do it. There's no way around. So projectile y direction motion equation. So Sy equal Sy0 Vy0 t plus half of gt squared. What did I write here? It's the equation for the projectile y direction distance, right? Everybody seen this equation? We did it here in class as well. Remember at the beginning of I believe exam 1, where we have dealt with that, right, Elisa? Exam 1. So long ago, right? So basically, just to give an idea here, okay. So this is the final y, right, which is given 7.5. Now it depends. If your datum is where the ball started, then this value will be 0, right? Okay, so this is 0, this is 7.5. The initial y direction velocity, is it there? No. The ball is only moving in what direction only? X direction, right? You're throwing the ball or playing. So it's on X direction movement initially. So no y direction. So this will be 0, this will be 0, right? You know this value, 7.5, because that's what 7.5 feet, right? And the g 32.2. You know, find the value of the t. The t means what? The time required for the ball to go from when you are hitting it, right? The tennis ball to go from here to the 20 feet. Everyone got it? That's all you got to do. See if you can do that. Okay, so I'm getting the class note. So you have this 7.5. this is 0 equal, you can write it as like a feet here, and this is half of 32.2 feet per second square, right? And this feet will gonna cancel out, and then you have this t. Obviously you have this t square here, right? You're gonna rewrite things, all things around, so you'll have this 7.5 multiplied 2 divided by 32.2, okay, second square equal t square. You're going to do the math, the t value is going to become 0.6825 second. Because this value is in square, so you got to find the value of the t, you got to do what? Square root. You understand? Okay, so that's the value we're going to find. And then can you find the if you know the time value, can you find the x direction velocity or the y direction velocity? So let's start with this equation, see if you understand this equation. I'm going to talk more about this. So bv y, bv0y, v0y plus gt. All right, why did I put a 0 before the subscript b? Now you see that b here, vb, is the velocity of the tennis ball after it hit the ground, right? But before it hit the ground, it does have a different velocity. And the projectile equation can give us only before scenario, right? Why? Think this early. So you're hitting the ball, right? So the ball is flying. It's on the air. Before it hit the ground, all the equation that I'm using, the projectile equation, has everything to do before it's hitting the ground, right? So that's BV0. 0 is referring to before hitting the ground. But B, the B subscript is referring to the point B where it is hitting. Make sense? Everybody got it? Okay. So if that's the case, let me start moving on. Whatever reason, my thing's just getting off momentarily. All right, let me move on. So I know this equation. So now I should be putting a little bit brief about this. What is that? So note on the note here. So on the note, so this BV0 y is referring to before impact. This y direction. There is like x and y direction. Remember, the ball is hitting the ground at an angle, right? So both y and x direction velocity. So this is the y direction velocity at point B. That one is so important. At point B. Need to understand that. So okay. So then you'd be doing the solution. So BB0y should be equal to, this initial velocity was 0. I did talk about it, right? So before I'm hitting in y direction, in x direction it does a velocity, and then you have this g multiplied t. You're going to start plugging the values like 32.2 feet per second square multiplied by the time is 0.6825. The time value we just found, right? Second. So this second square second we're going to cancel out. So bv0y, if you're going to do the math, you're going to come up with the value of 21.98 feet per second. Now, if I'm going to ask you the velocity of really so many things happening here. Okay, I'll once you're done with that, I'm going to emphasize on that. See, while you're writing it, once you're done with the writing, while you're writing it, think about it. So basically, it has 2 points. First of all, easier to understand. First, point A is when the ball is started to move, right, Aline? That is point A. So in point A, do you have y direction velocity? No, we have only x direction velocity. Now you see, I did use this symbol here, V0y. Do you see that? What the V0y means? V0y means this at point A, y direction velocity. That's the same thing, right? but I didn't quite identify that way. You can identify that way. It doesn't really matter. But point A, x direction velocity is the total velocity. Does it make sense? So point, because that's how it starts. So now, can you write this? Like point A, x direction velocity with this x distance that it traveled. Do you know the x distance that it traveled? So it's 20 feet, right? So can you write this 20 feet equal this velocity multiplied the time? This is the x direction velocity only at point A. Make sense? So that's how we're going to find the VA, or you can say V0x if you'd like to write it that way. So that's what I'm saying. It's a little bit tricky to understand. So it has three different scenarios. One is point A, where we have only x velocity VA. Another one is at point B, where before the impact and after the impact, two different velocities, right? It's a tricky problem. And in final exam, you'll be expecting this kind of problem. This is a take-home exam. Take-home, you always get challenging problem. Okay. All right. Okay. So just hang in there a little bit. Would be done soon. If you absolutely have to go, then go. It's all right. Then watch the video lecture later. All right. So I'm gonna next deal with this. D equal VAT. Now, anybody remember what is D? 20. Yeah, that is 20. Everybody see that D on the sketch? All right, so I do know that value. So I'm gonna write the value of dA, which is D by T, and that is, everybody say 20. I'm gonna just simply write the value. So 20 feet divided by the T is 0.6825 second, right? And the VA value would become 21.98. Oh, sorry, 29.3 feet per second. Why I'm just collecting all the values of all the velocities, right? We're gonna need them for the coefficient of restitution, E, right? Remember, that one has everything to do with the velocities. So then we'll be doing like coefficient of restitution. So coefficient of restitution, that value is given, by the way, 0.7. And coefficient of restitution happen where? At point B. Remember that, right? So I'm gonna say this E equal 0.7, and this is equal BVY divided by BV0Y. So this is in Y direction velocity that I'm taking only. Remember, in coefficient of restitution, we can either use the X direction velocity or Y direction velocity. Everybody remember that? Okay. So I got to put some note here, okay, because this is getting a little bit out of hand. So you would like to write before and after. So this is note only. So before and after the impact of the ball at point B in Y direction only, okay? Okay, in Y direction. Now what you're gonna do, you're gonna rewrite this whole thing as like BVY equal 0.7. Now remember, your goal is not to find the velocity at point B before the impact. Your goal is to what? Find the velocity after the impact, right? So these equations are gonna give you the velocity after the impact in Y direction, not in X direction yet. We're gonna find the X direction velocity. Everyone understand? Everyone got this thing? All right, so you gotta just simply plug the values of BVY0, which is, you did find it like 21.98. Remember, that's the value. So feet per second, and this would be 15.38 feet per second. This is BVY. All right, so this is BVY. All right, now the final one. This is the very final one. Okay, so conservation of momentum. So conservation of momentum in x direction, right? We just solved the y direction velocity. So in x direction, what are you going to do? So this is the thing that we just did before, right? Vox. Now before and after the impact, right? The velocity in x direction. That's what we're doing. So momentum is mass multiplied velocity. So that is the before the impact, and that is after the impact, right? And this mass is going to go away. So what does it tells me? It tells me my velocity in x direction is same as before and after. Does it make sense? It just tells me both are same. So now can I write this like bvx equal bvox, so before and after the impact, equal ba equal 29.3. Now you start make sense why I'm saying that. See, you can do the conservation of momentum again for A and B position, right? The mass is same, so the acceleration velocity is never changing. Everyone understand? And how did you find the acceleration velocity? From the distance d 20 feet, right? Yes. 0.8? Oh, it was in 0.8 over there. Please change it in the question, okay? I'm going to do it because my answer is based on 0.7, right? That's the e value you're referring? Yeah, you are absolutely right. Good catch, Ireland. So this e value they gave you as 0.8. I'm changing it to 0.7, and you may want to write it here 0.7 because my solution is based on 0.7. Okay. All right. So now we're very, very close to the end. So this is gonna give us this velocity in x direction, velocity in y direction. Now, if you know these two components, can you find the BV? How do you find it? You remember the Pythagorean? VVX, BVY. Everybody remember this? Okay, all you got to do is just plug the value and solve it. So you have this BVY, and then you're going to start to plug the value. So 29.3 square, 15.4 square root, and that's feet per second. Make sure you stick with the unit. And then you do have the value of, I don't have the solution of that. I'd like anyone to give me the value. Okay. Somebody else may confirm, but this is what you're going to get. And tan inverse should be equal BVY BVX. You know this equation, right? From trigonometry. And then you're going to just simply plug the values 15.4, 29.3. So that's the tan theta, right? And theta would be equal tan inverse. That's find theta after the impact. So tan inverse 15.4. You know this is feet per second cancel out. So 29.3. You're going to have 27.7 degree. That's the theta. I'm sorry, I had to stay a little longer today. But the second problem, again, to give you a quick review, we are hitting a ball. It's a projectile that we are zooming for a tennis ball that starts with sudden velocity in x direction. And after it hit, it has another velocity VV and angle. So we have to find this VV and angle, okay? So many things that we did on this problem, the coefficient of restitution E was given. Along those things, we had to use the conservation of linear momentum several times in both x and y direction. We had to use all the projectile equations to find the velocities as well, right? We have to find the time required for the ball to hit the ground, right? And finally, we were able to find the velocity and angle. Any question? Anyone? All right. Again, sorry for a little delay on this class today. But the other two classes could be a little bit longer also. But the goal is to, wrap it up by Wednesday. Me too.